Yes, friends. Now let us see one simple problem here. Now, what is the sum of square of some few natural numbers? Yes, as we have discussed in the last slide. Yes, what is the basic formula for this? N into n plus 1 to n plus 1 by 6. Yes, what is here n? N is 20. Here again 20 plus 1, okay, 20 into 2 plus 1, here divided by 6. If you do here this 20, 21, 41 by 6. Yes, friends, if you do this, yes, if you just substitute this, so the answer what you will get is 2870. 2870. So yes, next we'll continue. Now we will look the another one. Now what is the sum of cube of first 4 natural numbers? Okay, first 4 natural numbers. 1 square, 1 cube, 2 cube, 3 cube and 4 cube plus plus plus. Yes, so we know n into n plus 1 divided by 2 whole square. N into n plus 1 divided by 2 whole square. What is here n? N is 4. 4 plus 1 5 divided by 2. Yes. So this is square and this will become 100. Yes. Let us see, let us move on. Yes, friends. Now let us see the prime numbers. The number which is divisible by itself is known as the prime number. Yes, and there are some few properties of the prime number, like, okay, 0 and 1 is not a prime number. Why? 1 is not a prime number. Why? Because it has only one factor. Only one factor. And 0 is not a prime number. And one more important thing here, all prime numbers are positive. All prime numbers are positive. 0 is not a prime number. 1 is not a prime number. Why? Because it has only one factor. And 2 is the only even prime number. 2 is the only even prime number. If 2 is the only even prime number, the remaining prime numbers are odd. If the remaining prime numbers are odd, and the lowest odd prime number will be 3. These are some of the basic properties of the prime number which we need to remember. Yes. So we'll move on. Now friends, now how to find whether the number is a prime or not? There is another very important question. So how to find whether the number is prime or not? So let us take one example. Let us take one example here. Now 193 is a prime, yes or no? 193 is a prime number, yes or no? So 193, okay, it is nearer to square of which natural number? Okay, around 196. Yes, 14 square. 14 is equals to, yes. So 196 is the square of 14. 196, yes, 14 square is equals to 196. So 193 is nearer to 196. 193 is near to 196. Okay, fine. Now as we know the number, what do you mean by prime number? The number which is divisible by itself is known as what? Prime number. Now, so if the number 193 is a prime, then it should not be divisible by any number. It should not be divisible by any number. Now we need to check it out whether the number 193 is divisible by any other number. Then with which number we will divide 193 and identify whether that number is a prime or not. Whether that number is a prime or not. Look at here. This is with the help of this one simple what you call trick. We can easily identify. Now 14 is there. 196. 14 square is equals to 196. 193 is near to 196. Now less than 40, what are the prime numbers are there? Okay, less than 40, there are what are the prime numbers are there, and yes, how many are there? Okay, 2, 3, 5, 7, 11 and 13. Yes, 2, 3, 5, 7, 11 and 13. Now divide this 193 by all these number. Divide 193 by all this number 2, 3, 5, 7, 11 and 13. If that 193 is divisible by any other number, any number among these 2, 3, 5, 7, 11 and 13, then 193 is not a prime number. If it does not get divided by any number, then 193, yes, of course, definitely it is a prime number. Yes, friends, with this I made it very clear. Yes, 193 is a prime number. If you just take it out, oh, yes, look at here. 193 divided by 2. Yes, so 2 9s are 18, 2 6s are 12. Again, remainder is 1. So again, 193 divided by 3. 3 1s are 3 6s are 18. Again, 3 4s are 12. Again, the remainder is 1. Again, the remainder is 1. Again, here 193 divided by 5. Okay, so 5 3s are 15. 15 43. 5 8s are 40. Again, the remainder is 3. Again, 193 divided by 7. So 7 2s are 14, 53. 7 7s are 49. Again, the remainder is 4. So it is not. Again, 11. Okay, 193 divided by 11. 11 ones are again 8, 83. 11 sevens are again there is a remainder 3, 4, 5. There are 5 remainders is there. Again, when it comes to 13. Okay, 193 divided by 13, you do it again, there will be some remainder. So the entire 193 is not divisible by any other number less than 14. Otherwise, if you don't use this trick, then with how many numbers we need to divide it, and moreover 193 should and must be divided by those prime number which are less than 40, else again the number will go out of the box. So I hope now it becomes very clear for you, okay, how to identify whether the number is a prime or not. Yes, now friends, let us see some 2 example here. We will see some 2 example. Now the product of the product of any number and the whole number. The whole number, you take any number. So yes, it starts with 0. 0 multiplied with any number is again equal to 0 only. Let us take another example here. Now there are 4 consecutive prime numbers. And the product, there are this 1, 2, 3 and 4. This is the 4 consecutive prime number. The product of first 3 is 385. The product of first 3 is 385, and the product of last 3, is 1001. The first and last number are respectively. So this should come here. This has asked in UPSC Civil Service 2011. In 2011, this question has been asked. Yes, sir. Now look at here. Consecutive prime number. What do you mean by consecutive? एक के बाद एक. Now, what are the prime numbers that we have? We have 2, 3, 5, 7, 11, 13. 13 is there. 17 and so on. Let us take first 4. Okay. Let us take first 4. The product of first 3. The product of first 3 is 385. 385. 2 into 3 is 6. 6 into 5 30. Is it possible? No. Gone. So let us take again 3, 3, 5, 7, 11. 3, 5, 7, 11. 3, 5, 7, 11. 3 into 5, 15. 3 into 5, 15. 15 into 7, 105. Is it coming? No, gone. Yes. So let us try with another 5, 7, 11 and 13. Let us try with, okay, 5, 7, 11 and 13. Okay. So let us take first three. So 11 into 7, 11 into 7, 77 into 5. 5 into 7, 35. 5 into 7, 35. 35, 38. 385, 385. Yes, the number is coming. Yes, of course. So the product of first three consecutive, the product of first three number, prime number is 385. Yes, 5, 7, 11. Let me check the the product of the last. Okay, last three number is 1001. Let us see last three number 3, 11, 7. Let us see these 3, 11 and 7. Okay. Now let us see this. So, okay, 7, 11 and 13. 11 into 7 is again 77 and 13. Yes, yes, of course. So the product of first three consecutive prime number is 385 and the last product of last three consecutive number is 1001. So then what is the answer here? So what will be the first and the last number? What will be the first and the last number here? So the first number is 5 and the last number is 13. So where it is 5 and 13, the first is 5 and the last is 13. Yes, friends. So this is very good and interesting question which is asked in the UPSC Civil Service 2011. 2011. Yes. Now let us move ahead now. Now, friends, now again, what is twin prime numbers? Okay. Let us see some, okay, the twin prime number, composite number and rational number. The number itself, the name itself is indicate twin prime number. The name itself is indicate twin prime numbers. So here the difference between two prime number is 2. 5 minus 3, 2. 7 minus 5, 2. 11 minus 13, 2. 11 minus 13. 11 minus 13, 2, and so on. The difference between two prime number, if it is 2, then it is called as what? Twin prime numbers. Now then what is composite prime number? Composite prime number, the number which are divisible by at least one number except one, and number itself is known as what? Composite. At least, this is very important word here, at least and at most. I will explain you with this here. Okay, this is 0, 1, 2, 3, 4, 5 and so on till n. Okay, now when I say at least one, okay, so if this is 1, 2, 3, 4 and this is 5. 1, 2, 3, 4 and 5. So at least one, if I say at least the word at least and at most. At least is minimum. At least is minimum. At most is maximum. At least is minimum and at most is maximum. At least one, minimum it should be divisible by one number, then other than the number itself. Yes, other than the, except one and the number itself, it should be divisible by one. So it can be more than one. It can be more than one. It can be 2, 3, 4 and 5. It can be any numbers, but it should be greater than one numbers. Now when it comes to at most, for example, at most 4 number. Okay, at most 4 number means it is maximum 4 numbers. It should be less than 4 number. It cannot increase more than 4 numbers. Less than 4, but it cannot be increased. It cannot be more than 4. So at most and at least. At least, the word at least is minimum. The word at least is minimum. The word at most is maximum. The word at least and at most. Yes. Now let us move to the rational numbers. Let us move to the rational numbers. Then any number which can be expressed in the form of, yes, look at here, P by Q. Yes, where Q is not equals to 0. Those are called as what? Rational number. Why P by Q and the Q is not equals to 0. So this is called as what? Rational number. Why? Because P by 0 is infinity. P by 0 is infinity. Sorry. So then what do you mean by infinity? The word infinity means anything which is beyond the range. Anything which is beyond the range is infinity. Like for example, if I'm standing in an open space, I'm just having a view at the horizon. So how far I can see it? How far I can see it? And that the peak, what do you call, point, wherein I can see it, that is my range. Beyond that, it is infinity for me. The thing which is beyond my range is known as what? Infinity. Here also, so even when it comes to this numericals, so P by 0, 1 by 0 is infinity. It is beyond the range. So hence look at here, 3 by 2, minus 7 by 9, and 9, again here 5, minus 2, and so on. So these all are rational numbers. Let us move to the next slide. Yes, now irrational numbers. Yes, irrational numbers. Here two words is very important. Yes, non-recurring and non-terminating decimals are called irrational numbers. So these numbers cannot be expressed in the form of P by Q, where okay, PQ belongs to I and Q is not equals to 0. Yes, so if you take root 3, root 5, root 29 and so on, so you will get what? Non-terminating decimals. So whenever you are getting the non-terminating decimals, yes, whenever you are getting the non-terminating decimals, so those are called as what? Irrational numbers. Now when it comes to these real numbers, yes, real numbers. So both, yes, rational and irrational together is known as what? Real numbers. Rational and irrational numbers is both together is known as what? Real numbers. So friends, let us move. Let us take one example here. Let us take one example. So root 3 is irrational. Clearly he has given. Okay. Then root plus 3 is what? Question. Yes. Root 3 is irrational. So if you add anything, of course it will be having our what? Non-terminating decimal point. So again that also will be irrational. That the same. So even the answer will be irrational. Now friends, let us move on to the operation on numbers. Move on to the operation on numbers. Let us see, okay, fine, addition, subtraction, multiplication and division. Here I am not going to discuss addition and I am not going to discuss multiplication. You all are very well aware about addition and multiplication. Here, okay, just I am going to briefly discuss about two things, that is subtraction and division. Before moving, we will discuss about what? Subtraction. So what is the principle of subtraction? Just only one thing I would like to highlight here. What is the principle of subtraction? It is nothing but was greater number minus smaller number. Okay, 4 minus 3, 3 minus 4. 4 minus 3 is 1, 3 minus 4 is minus 1. So the principle of subtraction is, yes, principle of subtraction is greater number minus smaller number. Always you remember this. Now we will move on to this division. We will move on to the division. Let us see. Yes. Now friends, you have already solve number of problems based on the division. Here just we are going to define, okay, so dividend, divisor, quotient, remainder, and the questions based on this type. Okay, here some 4 vocabularies that we need to understand. Okay, So just I am highlighting as a reminder and briefing you about this division here. Okay, now look at here. For example, I have taken one example here. 225 divided by 25 is equals to 9. Again, I will take another simple example here. Like for example, okay, I will take example of 17. 17 by 4. Okay. 17 by 4. Okay. 4 into 4, 16. Remainder is 1. 4 into 4, 16. Remainder is 1. Now, 4 into 4 remainder is 16. And what is 17? What is 4? What is this 4? And what is this 4? And what is this 1? It is called as, now 17 is called as what? Dividend. Yes, 4 is called as what? Divisor. And this 4, yes, 4 into 4, this is called as quotient. And this minus 1 is called as what? Remainder. Remainder. So dividend by divisor, again quotient is equals to remainder. Now, so look at here, 4 into 4. So divisor into quotient. Yes. Divisor into quotient plus remainder is equals to dividend. Yes. So divisor into quotient plus remainder is equals to dividend. So this is how we will get it. This is how we need to just define. So this is very, very important. Dividend, divisor into quotient plus remainder. Now let us solve a example based on this. Okay. Find the dividend when the divisor is 13. When the divisor is 13, quotient is 30 and the remainder is 12. Remainder is 12. Okay. So what is this? Dividend, divisor, quotient, remainder. Okay. Now find the dividend. I need to find this dividend. Yes. I need to find this dividend. When the divisor is 13, shall I say x? X is the dividend. 13. Quotient is 30 and remainder is 12. Remainder is 12. Simply what is 13 into 30 plus 12. Yes, 13 into 30 plus 12. So 13 into 30 plus 12 is equals to what? X. Now look at here. 3 into 3, 9. This is 390. 390 plus 12. What it is? 390, 100. This is 402. This is 402. So what is this dividend? Dividend is 402. Now let us get the reverse answer. Whether I am getting the same remainder. What is the remainder? Remainder is 12 here. Let us see here. For example, here 402. Okay. 4 we will take. Okay. Wait. So 402. Yes. 13. Yes. Again, look at here. What is this? So this becomes again 390. Yes, friends. So this type of questions they might ask. Yes. So just we need to define and we need to understand dividend, divisor, quotient, remainder. Though you have solved many number of problems, but this is how just you defined it. Okay. So divisor into quotient plus remainder is equals to dividend. So this becomes very easy. So this type of questions also they might ask. Okay. They have now friends, let us move. Yes. Now let us see what is the BODMAS rule. Okay. So when it comes to V, okay, bar, B bracket of division, multiplication, addition and subtraction. Okay. Division, multiplication, addition and subtraction. So this is the bracket of, this is the bar. First we need to remove the bar, then we need to remove the brackets, then we need to first look at for the division, multiplication, addition and subtraction operation on that number. Let us see with the help of one example how this BODMAS rule what you call work. Okay. Yeah. Yes, this is how. So look at here, if we see here, if we see in this, yes, look at here, we need to go from the left to right. Left to right. First we need to see, remove the bar, bracket of this division, multiplication, addition and subtraction. Okay, so this is one example. Let us solve here one example. Actually, I have taken here one example. In the next slide we will take it. Yes, so like for example, look at here. So if it is, yes, minus 5 minus 10 bar is, okay, first you remove that bar and you, okay, do that, again you will get here 5. This is, yes, 5 minus 10 minus 5, again minus into minus plus, so again you will get here plus 5. Now, yes friends, let us take one example here. Look at here. First we need to see this bar. Okay, so 1 plus 1 divided by 2. Okay, the rest is same here. 1 divided by, okay, so again here 1 plus 1 divided by, friends, now I will write only those things which are here necessary. Okay, here 1 plus, this is 1 by 2. How much it is? 2 plus 1, this becomes 3 by 2. If this is 3 by 2, 1 divided by 3 by 2, 1 plus, yes, so 1 by 2, 1 plus 1 by 2. So this entire bracket, it becomes what? 3 by 2. Now 1 divided by 3 by 2. So first we need to, as per this, what is this? First we need to see the division. Okay, so yes, again here 1 divided by 2 by 3 is what? 2 by 3 by 2 is 3 by 2. So again what is here? This is 5 by 3. 5 by 3. Yes. So 1 divided, okay, again look at here. So this becomes 3 by 5. 1 plus 3 by 5. So again this becomes what? 5 plus 3, 8. So 8 by 5. Again here 1 divided by this. So this becomes what? 5 by 8. Friends, I have skipped almost all the steps, only those steps which is necessary. I have written all those only necessary steps. I hope this is very simple. This is just to give you a basic idea about the BODMAS rule, how we need to see, how we need to just work on that from left to right, division, multiplication, addition and subtraction. So I hope the remaining you have understood, so that I should have a very less time consuming. So I have just focused only on the important steps which is needed. So the answer is 5 by 8 as per this BODMAS rule, friends. Yes. Now, yes, friends. So this is what the BODMAS rule over. Now let us see. Okay. So divisibility, yes, divisibility by numbers. Divisibility by numbers. So there are few numbers are there that wherein we need to check it out whether that number is divisible by some numbers or not. 2, 4, 6, 3 and so on and so forth. Then how we need to, how we need to what do you call, identify okay, whether that number is divisible by that particular number or not. For example, divisibility by 2, divisibility by 2. Now, a example, number is given here. Number is given. So 358246028352. So etc. etc. So these all are divisible by 12. 2. How? So a number is divisible by 2 when the unit digit is okay 0, 2, 4, 6 or 8. 0, 2, 4, 6 or 8 here. So if you see here, it is the unit place 0, 0, sorry, it is 2, it is 0, it is 8, again it is 2. So if you find okay these numbers, okay, 0, 2, 4, 6 or 8 at units place in the given number, then again I need not to check and verify with the 2, okay, whether that number is divisible by 2 or not. So hence that number is directly divisible by 2. You can check it out here, 3582 by 2, okay, 2 1s are 2, 2 7s are 14, 2 9s are 18, again 2 1s are 2, gone, 2 2s are 4, 2 3s are 6, 0, 2 1s are 2 4s are, yes, 2 1s are 2 7s are and 2 6s are, yes, gone, no? Yes, all the numbers. So units at the unit place, if the digits are 0, 2, 4, 0, 2, 4, 6 or 8, then the number is divisible by 2. Now let us move 3. Now when a number is divisible by 3, when we can say a number is divisible by 3, yes, look at here example, let us say one example here, 4 5 3. So 4 plus 5 plus 3, yes, 4 plus 5 9, 9 plus 3 12. So 12 is divisible by 3, 3 into 4 12, yes. So the summation of, okay, all the individual number in the given number, if that number is divisible by 3, then the entire figure, the total figure, yes, it is divisible by 3. When the sum of the all digit of a number is multiple of 3, if it is a multiple of 3, then fine, done, over, then entire number is divisible by 3. Let us see the other one. Now next, let us see whether that, yes. Now when we can say a given number is divisible by 4, a given number is divisible by 4. Now look at here, if its last 2 digit is divisible by 4, this is we need to understand, last 2 digit, yes, 4 into 6 24, over, khatam. Then the last 2 digit is 24. If it is divisible by 4, yes, the entire given number 45024 is divisible by 4. Yes, friend. So there into units place in 4, units and tens both. The last 2 digit of a given number, if it is divisible by 4, then the entire number is divisible by 4. Now let us move with the divisible by 5. Okay, divisible by 5. A number is divisible by 5 if its last digit is 0 or 5. Last digit is nothing but units place. Units place. Look at here, 10, 25, 60. So it is 0, 5, 0 and so on. Yes, of course. Look at here, 5 into 2, 5 into 5, 25. Again, 5 into 12, 12 into 5, 60. Yes, done. Yes. Next. Let us move. Now, divisible by 6. Divisible by 6. When we can say a number is divisible by 6, yes. So, if a given number is divisible by both 2 and 3, if a given number is divisible by both 2 and 3, look at here, 2 into 2, 4, 2 into 4, 8. Yes, it is 48 is divisible by 2. Yes. Now let me check, 48 is divisible by 3. 3 into 1, 3, 6. Yes, 3 into 16 is 48. Yes, we can say 48 is divisible by 6. Yes, now again 24. 24, you will just look at here, 2, 12. Now 3 into 8, 24. Now 108, 108, 2. 2 into 5 and 4. Yes, again 108 divided by 3. So 3 into 3 and 3 into 6. Yes. So the given number 6, 2 into 3, 6. 2 into 3, 6. And the given number should be what you call divisible by both 2 and 3. Then the number is divisible by 6. We can say easily, we can say that the number is divisible by 6. Now let us move divisible by 7. Now let us move divisible by 7. This is little what you call here we need to have focus. Like when we can say, let us take one example here, 658. Okay, 658. 658 is there. Now 65. 6. Look at here, 658. Okay, 65 minus the last digit unit multiple of, it should be multiple of 2. You multiply with 2 over 65, 2 into 8, 16. 65 minus 16 is again 49. Yes, the 49 is divisible by 7. So this is little tricky. Okay. Okay. The given number. Okay. So whatever the given number is there. Okay. So you just what you call last last digit, that is units place should be double and should be subtracted with the first 2 digit, and the answer what you will get is definitely what you call divisible by 7. Yes, if the number, yes, at that lot, at that, then the number is divisible by 7 when the difference between twice the digit at unit place and the number form is either 0 or a multiple of 7. If the result what you are getting is if it is 0 or multiple of 7, yes, that given number is divisible by 7. I hope it's clear. Now let us move to the other slide. Let us move to the other slide now. Now let us see when a number is divisible by 8 and when a number is divisible by 9 now. Now a number is divisible by 8. 2 into 4, yes, 8. And if the number formed by the last 3 digit of the number is divisible by 8. Yes. Let us take with the help of one example here. Okay, last 3 digit. Now 832. If the last 3 digit 832, okay, is divisible by 8, then the entire number is divisible by 8. Let us see 832 divided by 8. Yes, it's gone. Okay, fine. Now let me check this 57832. 57832 divided by 8. Now let me check. Yes. Two to 4, 2 are 4. Yes. Yes. So yes, if you divide this, yes, definitely the number 57832 is divisible by 8. Yes. Now next, we will move it here. Now when we can say a number is divisible by 9. Look at here, a number is divisible by 3 and 9. Okay, so the what do you call, the pattern in which the number is divisible by both, it is same. When it comes to example, 9 is 6, 8, 4, 6 plus 8 plus 4. If the result, okay, if it is a multiple of 9, then of course the entire number is divisible by 9. Okay, 9 is, look at here. So 6 plus 4, 10, 10 plus 8, 18, 18 is divided by 9. Yes, 9 ones are 9 twos are 18. Yes, 18 is divisible by 9. Then of course 684 is also divisible by 9. So yes, friends, let us move now. Divisible by 10. Now divisible by 10. Divisible, a number is divisible by 10 if its last digit is 0. If it is last digit is 0, of course 0, 0, 0. Okay. So this 10 is very simple. 5 and 10 is simple. 3 and 9 is simple. Okay. Now we will move to another one. Divisible by 11 now. 11 is little very interesting. 11 is very interesting. Yes, look at here, friends. So this is the given number. This is the given number, and here odd and even position. Okay, 6, 4, 3. What is this? Odd position. And the remaining 2 and 0. Okay, odd position is 6 plus 4 plus 3, and even position is 2 plus 0 is 2. 10, 13. So this is 2. Okay. Now the difference between odd and even position, the result of difference between odd and even, summation of odd and even position, if it is equals to what? As the difference is, if it is equals to 0 or 11, then the entire digit is divisible by, then the entire digit is divisible by 11. Look at here, 13, 13 minus 2. What is 13 minus 2? It is 11. 11 is multiple of 11. Yes, of course. Then the entire number 30426 is divisible by 11 for sure. So this is really very interesting when it comes to a number when it is divisible by 11 here. So a question might ask you, they might give one some, okay, 6, 7 digit problem number, and there we need, there they might ask, okay, whether the number is divisible by 11, or they say that number is divisible by 11 and then find the value of x. In between 6 and 7 digit number, they will give one unknown number, 1 or 2 unknown numbers. So xx. So there you need to find out the x. And they give the hint clearly that number is divisible by 11. We will solve that one type of problem based on this 11 now. Next, a number is, now how we need to identify whether a number is divisible by 12 or not. 12, 3 into 4, 3 into 4, 12. So if a number is divisible by both 3 and 4, then the entire digit is divisible by both 3 and 4. So now next, it divisible by 14, divisible by 14. So 2 into 7, 14. 2 into 7, 14. So in example, okay, if a given number is divisible by both 2 and. So yes, we need to understand the meaning of and or but. So and goes in positive, or goes in option. Yes, may or may not. But goes in negative, opposite. So if I disagree, or if I disagree with someone after listening to something, I say okay, but however I disagree with that. So but is always comes in negative and comes in always positive. So when it comes to positive means both, and addition means both 2 and 7, both should be. A given number is divisible by both 2 and 7. Hence the number, if you see 4242, if you see 4242, is it divisible by 2? Yes. Okay, now 4242, is it divisible by 7? 7 into 5, 35. 7 6 are 42. 6 6. Yes. So yes, the given number is divisible by both 2 and 7. Hence the number is divisible. Hence the given number is divisible by 14. Now let us see whether a number is divisible by 15 or no. Now, okay, let us take this here one example, 4, 5, 4, 5, 4, 5, 4, 5. So, yes, again 3 into 5, 15. So the given number should be divisible by both 3 and 5. Okay, so if you see 3, 3, 1, 3 into 1, 3, 3, 1, 3, 5, 3, 1, 3, 5. Yes, it is divisible by 3. And again 4, 5, 4, 5, it is divisible by 5. Yes, of course 5. Yes, it is divisible by 5. So it is divisible by both 3 and 5. Hence the entire number is divisible by both by 15. Yes. Now let us see. Now, how we need to check it out whether a number is divisible by 16. Number is divisible by 16. A given number is divisible by 16 if its last 4 digit. Fine. Last 4 digit is divisible by 16. Yes, if you see here, yes, 7536, 4 into 4, yes. Again, yes. So, yes. So the given number is yes, it is divisible by 16. Now when it comes to a number is divisible by 25, 25. Yes, so a number is divisible by 25 if the last 2 digit, yes, last 2 digit is divisible by 25. 5, 10, 15, okay. So this 25, it's very, very easy. Last, okay, last 2 digit. If the last two digit is, if it is divisible by 25, if it is divisible by 25, yes, of course, the entire given digit is divisible by, the entire given digit is divisible by 25. Yes. Last slide we see, yes, friends. So here we will continue in the next session, the another portion of number system in part 2. Till then, I hope I hope you have what do you call, you, the concept have been made it very simple and very easy for you. So we'll meet you in the next session. Thank you so much. Allah.